We're told that if a PMOS FET with W and L, both are in micrometers, is biased in triode with a VGS and a VDS, what is the on resistance of this MOS switch in ohms? And we're also having a VDP and a K apostrophe P value as well. So the first thing we're going to look at is the fact that it is a MOSFET. Now, PMOSFET, MOSFET doesn't really matter right here because we were trying to find resistance. So we just have a FET. This is the important part. We have a W and an L, and both are in micrometers. So we're going to pay attention to these units. We'll come back to them in a second. It's biased in triode, and so we're going to look at the triode MOSFETs as switches. We can use this resistance formula right here. We have our VGS and VDS. That is also good as well. If we wanted to go more in depth with this, we could use like this formula, this I formula, and plug it into here. Resistance is equal to voltage over the current, but I haven't tried that, so I'm not sure if that would still work. But I'm just going to be using the equation that we have right here. So for this equation, if we plug in the values that we have, we're going to have our RDS is equal to, we are going to have, and this is the denominator part, we have our K prime N, which is going to be a 40 times 10 to the negative 6th. And then we have our W divided by L, so that's 74.1 divided by 1.1. Now notice how I'm not putting in the meters, the micrometers, and that's because since they're on top of each other, they're going to cancel out. Now we have a VGS, which is 1.6, and this is an absolute value of it. So we have 1.6 absolute value minus, now it doesn't tell you here, but this VTP right here also needs to be the absolute value. So that's important to note. We're going to have minus a negative 0.5, but again, it's going to be an absolute value, so it's going to come out as 0.5. And then we're going to end this line. We can put our little division bar. It's pretty crooked, but that's okay. And this is all underneath 1. So if we were to plug this into a calculator, we're going to get 40 times 10 to the negative 6, 74.1 over 1.1, 1.6 minus 0.5, and that's just 0.5 because of the absolute value. And then for our answer, we're going to get approximately 337 point, and then we can just round it to 4. So 337.4 is going to be your answer. And that's how you would go about solving for this problem and anything like it. This is the on resistance of our MOS switch in ohms. So that would be the units here if we wanted to do that.